In this video, I'm going to discuss one of the questions from ISRO 2018 EC. So let's start. The question says, let x of e to the power j omega equals to n equal to minus infinity to infinity x of n e to the power j omega n, and x of n equal to 1 by 2 pi minus pi to pi x of e to the power j omega e raised to j omega n d omega. Just by looking at this, we can easily identify this is a question of discrete time Fourier transform. And if x of e to the power j omega, that is transform, is given as 1 upon 1 minus 0.2 e to the power minus j omega into 1 minus 0.1 e to the power minus j omega, then what is x of n in terms of unit discrete step function? So let's be very clear with one of the concept of discrete time Fourier transform. It is how to identify it. We know the discrete time Fourier transform in frequency domain is what? Discrete, and since it is transform, so transform means it is aperiodic. So in frequency domain it is discrete and aperiodic. See, this is discrete, that is why n equal to minus infinity to infinity, the limit is in terms of n, not in terms of t, and it is a periodic function, that's why we are integrating it in the complete limit. And one more thing we need to notice here is, if frequency in frequency domain, if the signal is discrete, then discrete behavior in time domain will correspond to periodic nature. Discrete behavior of a signal in frequency domain corresponds to periodic nature in time domain, and correspondingly aperiodic nature in frequency domain corresponds to continuous nature in time domain. So if a signal in frequency domain is discrete and aperiodic, in time domain it has to be periodic and continuous. We can see we are taking the limits from minus pi to pi, that means we are considering just one period, that means my signal is periodic and it is continuous. That means I'm not taking the summation, I'm taking the integration. So this is discrete time Fourier transform. So we need to find out inverse DTFT of x of e to the power j omega. What is e to the power j omega? E to the power j omega is nothing but z in z transform. So to make it easier, we can do the conversion. We can write it as x of z equals to 1 upon 1 minus, this is 0.2 z inverse into 1 minus 0.1 z inverse. This can be further written as z upon z minus 0.2, one more z will come, this, and then z minus 0.1 x of z. It's always handy if we are taking one z towards this. So if it is x of z by z equal to z upon z minus 0.2 into z minus 0.1. Now take the partial fraction. What will it be? It will be some constant a plus b, and if we are going to calculate the value of a and b, it is very simple. If you want to calculate a, put z equal to 0.2 in this. If we are putting z equal to 0.2 in this, so 0.2 upon 0.2 minus 0.1, that will be 2. So this a will come out to be 2, and similarly to calculate b, put z equal to 0.1 in this equation. If we are putting z equal to 0.1, barring this, we have to put in this one. We don't need to consider this, otherwise this complete term will become infinity. Simple partial fraction coefficient solution. So 0.1 upon 0.1 minus 0.2, that will become b equal to minus 1. So x of z by z equals to a, that is 2 upon z minus 0.2 minus 1 upon z minus 0.1. And from standard results of DTFT, we know that a raised to power u of n DTFT of a to the power u of n is equal to z upon z minus a. Also, actually DTFT of a to the power n u of minus n minus 1 is also equal to minus of a to the power n u of minus n minus 1. For this, DTFT is also equal to z upon z minus a. But only difference is in their ROC. ROC for above 1 is mod z greater than mod a, and for this one ROC is mod z less than mod a. Okay, well, the options are only given in terms of u of n, so we don't need to consider the we don't need to consider option for u of minus and minus 1. So we can start taking the inverse z transform. So x of z equal to 2 times z upon z minus 0.2 minus z upon z minus 0.1, which will correspond to 2 is a coefficient, and comparing this equation, standard equation, with z upon z minus 0.2, so a value will come out to be 0.2 raised to the power n. U of n minus 1 is the coefficient over here, and what is the value of a? A value is 0.1 raised to the power n u of n. So x of n is nothing but this value. And checking with the option, we can see this answer correspond to option A. Only thing from this question we need to remember is the discrete time Fourier transform, or as a matter of fact any transform. If we are talking about, if a signal's behavior in one domain is discrete, then in other domain in different domain, that discrete behavior will correspond to periodic nature. And similarly, in one domain if a signal is aperiodic, then in other domain aperiodic nature will correspond to its continuous nature, and this is vice versa. So discrete will lead to periodicity and aperiodicity will lead to continuous nature. Similarly, if a signal is continuous in one domain, in other domain it will be aperiodic, and likewise if it is periodic in one domain, it will be discrete in other domain. I hope this is clear. Thank you.